You know, when you pick up a rock, what do you see? Probably just a rock, right? Well, today, we're going to completely change how you look at them. We're about to uncover these incredible hidden stories of ancient movement, totally frozen in time, right inside a solid piece of stone. I mean, it sounds kind of crazy, doesn't it? Rocks are pretty much the definition of static, of something that doesn't move. But just think about that question for a second. Can a seemingly lifeless object actually record a dynamic event from millions of years ago? Well, the answer is a huge, resounding yes. And this right here is the key to understanding everything we're about to talk about. It's the perfect analogy. These patterns you see in rocks, they aren't just random. They are literally the planet's own fossilized footprints, telling us exactly what was going on in that one spot eons ago. Okay, so let's get into the how. How does a fleeting moment, a gust of wind, a flow of water, get permanently etched into solid rock? It's all about that flow leaving behind its fingerprints. Here's the official textbook definition. But the words you really want to hang on to are record the conditions. See, these structures aren't just accidents. They're a direct result of the physics of how sediment, sand, silt, mud, gets moved around and then settles down. It really just boils down to this simple three-step process. First, something has to move the sediment. As it moves, the flow sorts and arranges all those little particles into specific shapes. And then, and this is the critical part, if that arrangement gets buried quickly, it gets preserved, hardened into a permanent record. So simple, but so powerful. All right, so now that we know how it happens, let's put on our geological detective hats. We're about to go through a quick field guide to some of the most common clues you can find out there. A guide to reading these amazing stories of frozen motion. So our first clue is something you've probably seen with your own eyes. Maybe at a beach or walking along a riverbed. Ripple marks. They are, quite literally, tiny waves of sand that got frozen in time. But not all ripples tell the same story. And this is where it gets really cool, because the shape tells you a very specific story. If the ripple is symmetrical, with those sharp peaks and rounded valleys, it's telling you the water was just sloshing back and forth, like waves washing up on a beach. But if it's asymmetrical, with one gentle slope and one steep slope, that is the unmistakable signature of a current that was flowing in only one direction, like a river. And get this, the steep side points in the exact direction the water was going. Okay, let's move on to our next clue, and you'll see how these ideas build on each other. This time, we're not just looking at the surface of the rock, we're looking inside it, at the layers themselves. We're looking for something called crossbedding. Crossbeds are these beautiful slanted layers that you can see cutting across the main flat layers of rock. They actually form as sand dunes, whether they're huge desert dunes or little ones underwater. Migrate with the current. The slope of these internal layers points directly in the direction of that ancient flow. Geologists call it the paleocurrent. It's basically a fossilized compass. Now, our third clue tells a totally different kind of story. It's not about a nice, steady current. This one is about a sudden, super high-energy event that just fizzles out. This is graded bedding. I want you to picture an underwater avalanche, this turbulent cloud of mud and sand rushing down a slope. As it starts to slow down, what do you think happens? Well, the biggest, heaviest chunks of sand and pebbles, they drop out first. Then the medium-sized grains settle out. And finally, all the finest, lightest particles of silt and clay just gently rain down on top of everything. What you're left with is a single layer that grades from coarse at the bottom to fine at the top. A perfect recording of that one event, losing its steam. Okay, from the deep sea, let's head up to the shoreline. Clue number 4 is totally unmistakable. Mud cracks. I mean, you know exactly what these look like. Their formation couldn't be simpler. You have wet mud, it gets exposed to the air, it dries out, shrinks, and then cracks into those classic polygon shapes. So when you find fossilized mud cracks in rock that's millions of years old, it tells you with absolute certainty that this exact spot was once wet and then it was exposed to the open air. It's a dead giveaway for environments like tidal flats or lake shores that dry up from time to time. For our final clue, we're going to shift our focus a little bit. We're moving away from wind and water and onto life itself. These are called biogenic structures, or you might hear them called trace fossils. So, we're not talking about the fossilized bones of an animal here. We're talking about the fossilized evidence of what it was doing. The burrows it dug into the mud, the tracks it left behind, the little trails it made as it crawled across the ancient seafloor. These traces tell us for sure that life was here. And they can even give us clues about the environment, like whether there was enough oxygen in the mud for little critters to survive. So we've got ripples, cross beds, graded beds, mud cracks, and burrows. Okay, so what? Why does collecting all these clues matter so much? Well, because when you start to put them all together, you can turn a static, boring rock face into a dynamic motion video of the past. By reading these structures, geologists can reconstruct entire ancient landscapes. They can look at a rock and say with confidence, this was a fast-flowing river, or this was a quiet, deep part of the ocean, or this was a desert with massive sand dunes. They aren't just guessing. The rocks are literally telling them exactly what happened. Okay, let's bring it all home and focus on the really big takeaway here. We've decoded the clues, now let's make sure we understand the hidden story of the rock itself. So let's do a super quick recap. You can see how each of these structures is like a key that unlocks a specific piece of the puzzle. Ripple marks? They tell you about the flow. Cross bedding? That's your ancient compass. Graded bedding tells you about a sudden event. Mud cracks prove there was air. And burrows show that there was life. If you remember just one single thing from our time together, please make it this. We're moving way beyond just saying, oh, that's a piece of sandstone. We're now reading the story inside that sandstone, the story of how it got there. When it comes right down to it, these patterns are the Earth's memory. They're a high-fidelity recording of ancient worlds in action, just sitting there, waiting for us to press play. So the next time you're out on a hike, or maybe just walking past a stone building downtown, take a second and look closer. Don't just see a rock. Look for the layers, look for the ripples, look for the cracks, and ask yourself, what story is this rock trying to tell me?